Students, this is Miss Hughes, and today we are looking at simple probability. In general, the probability of an event happening, in order to calculate that probability, we need to count the number of ways the event can happen, the outcome that we want, divided by the total number of possible outcomes. And we'll see how that goes with one example, and then we'll use this example to show two important probability rules. So when I roll a normal fair dice, there are 6 things that can happen. I can get a 1, 2, 3, a 4, or a 5. Or a 6. There are 6 possible outcomes. Okay, so we want first of all the probability of getting an odd number. The odd numbers here are 3, 5, and 1. So there are 3 ways I can get an odd number out of 6 possible outcomes, and that's the same as 1/2. For B, they're asking for the probability of an even prime. So an even prime number, I think the only one is 2, so there's only one way that can happen out of 6. For C, probability of an odd prime number. Let's see, odd prime numbers would be 3 and 5. Remember, 1 is not prime because it only has one factor. A prime number has to have exactly 2 factors. So 3 and 5, which is 2 ways that can happen out of 6, and that's the same as 1/3. And then D asks the probability that a number is either prime or even. So it can be prime or even. So it could be 2 for prime, 3 for prime, 5 for prime, but it could also be even, which could be 4 or 6. So 5 of those numbers are prime or even out of 6. All right, let's now see how that would have looked with a Venn diagram, because quite often a Venn diagram will be a useful way to solve probability questions. So can you see we've got a Venn diagram here, and A is the even numbers, B is the prime numbers, and U is the set of all possible outcomes when I roll a dice. So for example, if we wanted the probability of an odd number, you can see quite quickly that it's 1, 2, 3 out of 6. Now we've got these 2 rules in here, and they are quite important. So for example, complementary events. If I wanted the probability of not getting a 2, so the probability of not getting a 2 is actually the same as 1 minus the probability of getting a 2. So probability of not getting a 2 would be 1 minus the probability of getting a 2, which is 1/6. And 1 minus 1/6 is 5/6. So basically complementary events, A and not A apostrophe, add up to 1. And then we've got this rule here, and we'll see how it applies with this last question that we did. The answer that we got for this question was 5/6. So we're expecting an answer of 5/6. And let's see how we would have done this question with this particular rule. So we're looking for the probability that it's either A, which is even, union B, which is prime. Now the rule says that's the same as probability of A, so probability of even, which is 3 out of 6, plus probability of prime, which is also 3 out of 6. But if you think about it, we've counted 1, 2, 3 out of 6, and 1, 2, 3 out of 6. We've actually counted that 2 twice. So this rule tells us to subtract the intersection. So subtract the probability of a 2, which is 1 out of 6. So 3 out of 6 plus 3 out of 6 minus 1 out of 6 is actually 5/6, which is the answer we expected. And that's the end of the podcast.